What's going on everyone, this is Gaurav and welcome to my learning channel. So in today's video, we'll learn about index, loc and iloc in pandas. Now, these are very important and handy functions which you might need to use it again and again in your day-to-day life with pandas. So without any further delay, let's get started. So first, to get started with index, as per the documentation, the index of a data frame is a series of labels that identify each rows. The label can be integer, string, or any other hashable types. There are a few things that I would like to highlight as a key property for index. First one is it doesn't have to be an integer, it can be a string as well. And second one is it doesn't have to be unique. So say for instance, if you have a data which has a customer details and one of the key variable is, let's say, country or a state of the customer, which is not unique for the customer. So multiple customers could have the same state or the same country. You can go ahead and use that as an index as well. So in the coming few minutes, we will take a look at a few of the examples like that. Now you might be thinking that why is it that index, which is used to identify a particular row, is not unique at a row level? This is because pandas index solve dual purpose. Not only it can identify a row uniquely, but it is also used to identify and reference a group of rows together. Now, if it is not very clear at this point in time, that's totally fine. Once we go through a few of the examples, it will become crystal clear. So first of all, let's go ahead and load the data that we are going to reference today. Let me just quickly go ahead and run the query. Now let's take a look at the content of the data. df1.head5. For today's data, you have four variables. You have customer ID, you have name, age, and state of customers. Now this particular data frame is unique at a customer level. So that's why for every customer, you will have only one record. The second variable is the name of the customer. Now, as you can see that I am fairly lazy and that's why I put the name as like A, B, C, D, E. Age and state of the customers are self-explanatory. Now on the left hand side, you can see that there are some numbers written. So you have 0, 1, 2, 3, 4. Now, if you take a look at the entire data frame, you will see that this number keep on getting incremented by an order of 1. So you will have 0, 1, 2, 3, 4, 5, and it just keeps going on. So for any of the data frame, unless you specifically specify, this number is unique at a row levels. So you will not see the same number to be repeated again. Now this is your default index, which is assigned by pandas. Let's take a look at the property and see if everything is satisfied here or not. Now, as per the property, indexes are the label that can identify each rows. Yes, we can go ahead and do that with the help of these numbers. Second one, it doesn't have to be integer. It can be string as well, which is totally fine because in this case, these are integers. And the third one is that it doesn't have to be unique, as for example, country or state in the customer data. In this case, it is unique at a row level. So all of the properties are satisfied. Now, given the huge amount of the data that you have in df1, I'm going to go ahead and make another data frame, which is df2. And I will have just top 10 records from df1. This way, we will be able to reference the entire data frame for the rest of the video. So df2 is equal to df1.head10. Now, in order to see what is the current index that has been assigned to a particular data frame, the command is df2, which is your name of data frame dot index. Now you can see that the range index is starting 0. It starts from 0, stop 10 because you have 10 rows. That's why it just stops at 10. And there's a step of 1 because it keeps on getting incremented by the order of 1 for every row. Now, this is the default index that has been assigned by the system. You can also go ahead and change the default index. So you can make any of these columns as your index. Let's go ahead and do that. So the command for the same is df2.set_index. And then afterwards, you specify the name of index. So let's say, for instance, I want to go ahead and use a state as a new index. So I'll go ahead and write it as a state. Let's quickly trigger it. Now you can see that something has changed in the out. So earlier on, you can see that these four columns are appearing on the right hand side. And then the left hand side, you have these numbers, which is coming without any column name. This was your default index. But now you can see that you have just 3 columns, which is customer ID, name, and age, which is appearing on the right hand side. In place of your default index, you have a new index assigned, which is a state, which is what we wanted to do. However, if I go ahead and take a look at the content for df2 again, you can see that nothing has changed. Even though we assigned a new index, which is set index is equal to state, nothing has changed in the df2. This is because something is missing in this particular code. Let's go ahead and make that change. In order for you to go ahead and make any change in the data frame itself, you will have to write an additional command, which is in place is equal to true. So let's write that in place is equal to true. Now let's take a look at the content for df2. So you can see that df2 now has changed. You have a new index assigned, which is state, which is what we wanted to do. So this is how you assign a new index to any of the data frame. Now you can also go ahead and reset the index and go back to the default setting, which was all of these variables were on the right hand side and the default index was 0, 1, 2, 3, 4. So the command for the same is df2.reset_index. And again, we'll go ahead in place equals to true. Now let's take a look at the content for df2. Probably just stick to top 5 rows. So these are all of the variables in your data frame and your default index is back, which is 0, 1, 2, 3, 4. So one of the key usage for index is to effectively parse through the data frame, which could come in handy for data filtering, etc. So let's shift the gear a little bit for a minute and understand the concept of loc, and then we'll come back to the indexes again, because loc is something which will help you reference a certain part of a data frame. So in general, loc is used to get the detail of the data frame for a specific row and column. So by default, the syntax is going to look something like df2, which is your name of data frame, and then afterwards you will write loc, which is name of the function, and then inside the big bracket you will write the row or rows, comma, columns. And these are the rows and column that you would like to reference. Now, this is not the actual command, so I'm going to go ahead and comment it out. Now, let's take a look at the example for df2. So let me quickly write a command here, which is df2.loc and then 1, comma, state. Let me quickly run this and then I'll explain what's happening. So as an output, you can see ny. Now, as I mentioned earlier, if you want to use loc, then first of all, you will write the name of data frame. Afterwards, the name of function, which is loc. And then you have row or rows. So in this case, I have written 1, and then column, which is a state. So let's take a look at what is happening in this particular data frame, which is df2. So for the row, which is marked as 1, which is the, as you can see from this index, this is the second row. And for the column, which is marked as a state, which is this first column, you can see that the entry is ny, which is what you see as an output. So let's take a look at another example. In this case, I'm going to go ahead and replace 1 with 2. And rather than calling it a state, I'm going to go ahead and go for name. Now you can see that for index 2 and name, you have the entry CCCC, which is what you can see as an output. Important thing to note here is that unless you explicitly specify, the first entry is your default index for row, and the second one is your default name of the column. Now, these are some of the most basic examples of loc. Now, there are a lot of permutation, combination, and changes you can do on top of it. So say, for instance, for this row number 1, if I want to see the entire row rather than just like state, all I will have to do is just replace state with colon sign. Now with this, you can take a look at the entire row. So for row number 1, which is this row, these are the entries, which is ny2bbbb and 26, which is what you can see as an output here as well. So state is New York, customer ID 2, name B, and age is 26. You could also specify the range for both row and column number. Let's take a look at an example for that. Let's say rather than looking at just row number 1, I want to take a look at row number 1 through 3. So for that, I will go ahead and use 1:3 and comma. This is for your row number, and then comma. So if you want to reference all of the column or all of the rows, you will go ahead and write colon sign. Let's quickly run this code. Now you can see that you are getting the details for row number 1 through 3, which is 1, 2, 3, as you can see here, and you're getting all of the columns. So you had 4 columns in your data frame. That's why you're getting 4 columns as an output. So as you have mentioned the range for rows, you can also specify the range for columns as well. If you want to do that, the command is, I'm going to go ahead and copy this first. The command for the same is here, you will go ahead and write the starting point, and then afterwards you write the end point. So let's say I want to take a look at all of the entries between customer ID. So let me copy this and paste it right here. And then apart from that, I also want to take a look at age. So I would like to take a look at everything which is between customer ID and age. Let me quickly go ahead and put the codes here. You can see as an output, you have row number 1 through 3 on the screen. And for the columns, you have customer ID through age. You don't have any more state because you did specify that I would like to take a look at everything which is between customer ID and age. Now, if you don't want to specify the range, but rather you would like to specify a specific entries, in order to do so, all you have to do is just replace this with a list. So let's take a look at an example for that. So now I'm going to go ahead and put a bracket here. So let's say, for instance, I don't want to see everything which is between row 1 and 3, but rather I would like to see only row 1 and row 3. Then this is how I'm going to write. So you have first list, which is row 1 and row 3. And you have a second list where I want to take a look at only customer ID and age of the customer. This is how your code is going to look like. Let's trigger this. Now you can see that as an output, I don't have row 1, 2, and 3, but rather I have just row 1 and row 3. And same for the columns, I don't have everything between customer ID and age, but rather I have just customer ID and age of the customer. Okay, so now again shifting the gear and going back to index, because as I promised, we'll come back to the indexes once we understand loc. But before that, let me just go ahead and print the top 5 entries for this data frame so that you have it right in front of you. Sorry, df2, I think, so that you have it in front of you once I trigger the query. So you can see you have a variable called state, and these are the states in which the customer is residing. So you have Texas, you have New York, Michigan, and so on. Now you can see as an output, you have a default index, which is 0, 1, 2, 3, 4. So let's state as a new index. The code for the same is df2.setIndex, and then state in place is equal to true. This is something that we have already seen earlier in the video. So let me quickly go ahead and trigger this code. So df2.head5 now looks something like this. So you have a new index. So let's say if I want to take a look at the entries for all of the customers who are residing in Texas, the command for the same is going to be df2.loc and then big bracket. And within that, you will have quotes and then Texas, which is TX. So with this, you can see the entries for all of the customers who are residing in Texas. So in DF2, you have the details for all of the customers who are residing in all of the different states. But as an output over here, you have details for only the customers who are residing within Texas. So this is one key usage of loc, which is you can reference a certain section of a data frame based on a certain condition. Now let's add a few conditions on top of it. So as an output here, you can see you have three different variables. You have customer ID, you have name and age. Let's say I don't want to have all of these three variables, but rather I want to have just one variable, which is name. So the command for the same is going to be, first of all, you will write dataframe.loc Texas, and then afterwards you will write the name of the variable that you want to see, which is name in this case. So now you can see that you have a default index, which is state. And then apart from that, you also have a name as an output. Now, if you want to see more than one variable as an output, as we have seen in some of the earlier examples, all you have to do is just replace this with the list. So say for instance, I don't want to take a look at just name, but rather I want to take a look at name and age of the customer. I will go ahead and copy this, and I will go ahead and make a list of all of the variables that I want as an output. So in this case, it is name and age of the customer. Now you can see that you have a default index, which is state. And then on top of it, you have two variables as an output. So you have name and age of the customer, which is coming from this particular data frame. So hopefully this would have given you a good idea about loc and index. Now let's learn about iloc. I would say iloc is loc's close sibling. Here I in iloc stands for integer. So its function is very similar to loc, with a few key differentiating factors. So at a very high level, you could use iloc to reference a certain section of a data frame with the help of unique row and column combination. But you can go ahead and simply use the integers. So it doesn't have to be the actual name of the variable. So let's take a look at the example. First of all, let's take a look at the details of data frame again, so that you have it right in front of you in the screen. You have df2.head. Let me go ahead and reset the index first. Sorry, let me just put the in place is equal to true. So df2.head5 again. Now you can see that you have four variables. Now if I want to take a look at the details, which is coming in the row number 1 and column number 1. So the way to do that will be name of the data frame, which is df2.iloc. And then afterwards, you will specify the row number, which is 1, and then column number, which is 0. So now you can see that you have an output as ny, which is this particular entry. Now you might be thinking that this looks very similar to loc. So why can't we go ahead and use loc? Why do I have to use iloc? So let me go ahead and write the exact same query, but rather than let's just delete I here. So let's say you have df2.loc and then 1, 0, which is your row number and column number. Let's trigger this, and this will give you an error. This is because for loc, this row number and column number is specified by the index that you have. So your by default index was 0, 1, 2, 3, 4. So that's why you can go ahead and specify that here. But your column names were state, customer ID, name, and age. But you're specifying that as an integer, and that's why this is throwing an error. However, for iloc, you can reference a particular row and column by simple integers, which is your integer row number and column number. So in this case, this is 1 and 0, which is this particular entry. So let me just comment this out and run this again. Now, another key differentiating factor between loc and iloc is the representation of row and column. So let's understand this with a simple example. So say for instance, using iloc, if I want to take a look at the details for all of the customers who are between row number 0 to 2, and I would like to take a look at all of the columns. The way to do this is going to be df2.iloc, and then afterwards, this is your row range, and then you have a column, which is all the columns. Let's trigger this. Now you can see that you have details for these two customers and you have all of the columns. Let's write the exact same command, but for loc. So I will go ahead and copy this code here, and I'll replace iloc with a loc. So as an output, you can see the details of the customer, again, all of the columns and 3 rows. So using loc, you are getting 3 rows, while using iloc, you are only getting 2 rows. That's because when you're using iloc, the starting point is 0, which is your first row right here. But then this particular endpoint is not included as an output. However, on the other hand, for loc, this is your starting point, which is included, but your endpoint, as you write here, is also being included. So that's why the row number 2, you can see that as an output. So these are two main differences between loc and iloc. So hopefully this would have given you a good idea about iloc. Now, as I mentioned earlier, that all 3 of these are critical building block to understand. So feel free to check out this video again in case you forget something. And if you have any questions, please do drop it in the comment section. In our next video, we'll learn about data aggregation and ordering in Pandas. Thanks for staying with me so far. Wish you best of luck in your learning journey.